Okay, so now we're going to go into your Springboard and we're going to go to page 28, which you started on Friday regarding literal equations and solving for a variable. So we're still working on the same LEQ, which is how can I write and solve equations and inequalities. And this time we're working on what we call literal equations today. So today, literal equations are going to be our focus. So our learning targets today are solve literal equations for a specified variable and use a formula that has been used to solve for a specific variable to determine an unknown quantity. All right, so in your notes, you should have from Friday the definition of formula and the definition of a literal equation. So right now, I just want you to pause and think. I want you to think about what are some formulas that you know, some formulas from either math or science that you know. Go ahead and hit pause, and then we're gonna write down as many formulas as you can think of. So, for example, the area of a rectangle equals length times width. And you know other formulas for area, you know other formulas for volume, all of those things. So hit pause and write down as many as you can think of. So here are some of the most common formulas that I often see. Area equals length times width, volume equals base times height. The C, if we're talking about a circle, circumference equals pi times diameter. Area equals pi times radius squared. Area of a triangle is 1/2 times base times height. Those are all formulas that you have memorized. So now let's talk about like literal equations. So a literal equation is an equation with more than one variable. So if we look up here, a variable is just an unknown. But if we look up here, we actually have three variables. So we have A for area, L for length, and W for width. Here we have two variables, C for circumference and D for diameter. Pi is actually not a variable. Pi is just a symbol for an irrational number. So a literal equation is an equation that has more than one variable, but it can be solved for a specific variable. So I'm going to go ahead and I'm going to take a look at our equation for circumference, which is circumference equals pi times diameter. And I'm going to solve that for diameter. So right now I want to isolate my diameter so I could plug in other numbers and just get the diameter. So to do that, let me write down the original equation. So circumference equals pi times diameter. So to do this, I'm going to go ahead and I'm going to use inverse operations to isolate diameter. So if I want a diameter isolated, I see that it's multiplied by pi. So I would divide pi here, and whatever I do on one side, I have to do on the other. Sorry, that division sign's squiggly. So here they cancel, and what I'm left with is circumference divided by pi equals the diameter. And that's as far as I can go. I could rewrite that. That is correct right there. I could rewrite it so it's diameter equals circumference divided by pi. It doesn't matter what goes where on the equal sign. Like as you can see here, I just kind of flipped it. That doesn't matter as long as I have isolated the variable that I wanted to solve for. Okay. Great, so let me show you one more example, and this time I will do I'll do the area example. So if area is length times width, then the other way I could think about that, so if area equals length times width, and say I wanted to solve for length, I could divide out my width, divide out my width. So length equals the area, oops, or W, I said area. Length equals the area divided by the width, okay? Because they cancel, and then I had that left here. All I did was flip it, okay? And I do my L's in cursive so they don't look like ones. All I did was flip it, and that's how I got my literal equation. Okay. So now I want you to go ahead and do the try these A. So hit pause right now. You can work with a partner. And you're going to solve for x, then you're going to push play, and you're going to check your answer. So go ahead right now and hit pause and work with a partner, and then when you push play, you will check your answer. All right, so here are your solutions to the Try These A. And if you aren't quite sure how we did them, let me kind of walk through the first one with you. So if you are sure, you can just kind of skip ahead. So here it says solve for x. So the first thing I have to do is I have to subtract out my 7 because I do the inverse operations. So minus 7, they cancel. 3 minus 7 is negative 4. That's how they got the negative 4. And then again, to isolate x, I have to then divide out a. Divide out a. So my x equals, at that point, my x is isolated, and it's negative 4 over or divided by a. Okay? Then the same process kind of applied to the other ones here. C is a little bit different because C actually has like the other two have the coefficient with the x. C has like a number instead of another variable as the coefficient. So here you would do the same process that you would just subtract out d, and then you would divide the whole thing by negative 3. So those are canceled and that's canceled. Negative 9 divided by negative 3. So you can think of it this way. There, they cancel. 9 divided by 3 is 3. And here you have a double negative. So once again, that cancels and becomes positive. D divided by 3 would be what you're left with. Okay, please raise your hand if you have any questions during this process, or write your questions down, and we'll go over them as soon as possible after this. All right, so now I want you to go ahead and do the check your understanding. Once again, you need to hit pause, okay, because when you hit play, I'm just going to go ahead and go over the answers. Okay, so pause. You can talk to a partner. But once you hit play, I'm going to go over the answers. All right, so when you did both of those, the first one is that this is not a literal equation because there's only one variable. So when you solve for x, you should end up with an x equals something. So you should end up with like x equals, and I didn't go through and solve this all the way. 3, 10 divided by 3. It should be like x equals 3 1/3 or something. But regardless, you would get x equals a number. Okay, and that could be like a one solution, a no solution, and infinitely many, but it would be x equals a number. So then here, describe the similarities and differences. Your similarities are that properties are used to isolate a variable. Your differences is that the solution of an equation in one variable is usually a number. But in a literal equation, the resulting is still an equation containing more than one variable. So like when you solve this up here, x equaled a number. But when you solve a literal equation, you get your variable isolated, but it's still written in variable form. All right, so now we're going to go ahead and we're going to do this Try These B together. So here it says the equation t equals 13p plus 108 can be used to estimate the time in cooking. So t equals time. So I'm just going to go ahead and write time right above t so I know what it means. Minutes of a stuffed turkey that weighs p pounds. So p equals pounds. Solve the equation for p. All right, so I want to isolate my pounds. So t equals 13p plus 108. I'm trying to isolate the pounds. That's what I want by itself. So to do that, I'm going to subtract by subtracting out 108 minus 108. So I have t minus 108 equals 13p. Then I'm going to divide by 13. This acts like it's all together in a group. So I divide that whole thing by 13. That cancels. Okay, so I have p equals, and I could write it just like that, t minus 108 divided by 13, or I could write it as p equals t divided by 13 minus 108 divided by 13. And if I pause and check it, 108 divided by 13 is like a decimal, like it's a fraction. So I'm just going to go ahead and leave it. I'm actually going to go ahead and I'm going to use this one right here. So now the second part of this is it's asking me solve the equation for P, then find the weight of a turkey that requires 285 minutes to cook. So if I need 285 minutes, I would substitute in that 285 for my time. So I would do P equals 285 minus 108 divided by 13. Because now I can really quickly see all of my numbers together. And when I do that, and if you want to do that with a calculator, oh, hello, that did it to text. That's interesting. Oh, I hit the wrong pen. Okay, well, I don't need that. I'm just going to put that off to the side. I see what it did, though. Cool. Okay, so 285 minus 108 equals, and then divide that number by 13. So I get, in the decimal format, I get 13 and 6 to approximately 13 and 62 pounds. And I can round that to my nearest hundredth. I just have to add in there my unit, pounds. Great. So that's where it would be useful. If I needed to know, like, okay, well, it takes this long. How large is my turkey? Something that would be very useful. All right, so now in number 3, you are given all these different formulas that you'll use throughout life, and it wants you to solve for a given variable. So once again, I want you to hit pause, and I want you to go ahead and try to do this. When you hit play, we will check your answers. So right now, go ahead and hit pause. All right, so once again, I'm going to go ahead and show you the answers to number 3. So here are all of your answers. I want to point out that something like the v squared right here, that kind of just, that moves like as a unit. So that you don't like have to take a square root of something, it just moves as a unit. Same thing with like, so this right here, the P1, V1, that means the first measurement of the pressure and the first measurement of the volume, and then the second measurement of the pressure and the second measurement of the volume. It doesn't mean like P times 2 or like this weird P squared. See how it's it's called a subscript because it's below. A superscript would be above. So that's just all part of the same leveling. Like those P labeling. P2 kind of all sticks and goes together. And you'll see this is a very, very, very common physics formula that you'll use when you get into high school physics. Actually, I think all of these, pressure, kinetic energy, gravitational energy, they are all very, very common physics formulas. All right, so right now, go ahead and we're going to try a little bit more. I want you to try number 4 and 5. You can still work with a partner. You can still talk to those around you. But if you try them right now, go ahead and hit pause. And then once you hit play, I'll go over the answers once again. Right, if you have not done the answers yet, do the answers now, because here are the answers. So for the first one, C equals S divided by W plus I, or W plus 1. It should be W plus I. I don't know why they wrote a 1 there. It should be W plus I. And then here, being able to solve a literal equation allows you to write the formula for any quantity. So if you wanted to know what the width was and you had the perimeter and the length, you could then easily figure out like the width by manipulating a formula. All right, and then the next one, the last thing we're going to do, I want you to go ahead and try the 2-5 practice. So once again, I want you to hit pause. You can still talk with a partner, but make sure that you know how to do this because you're the one that's going to be responsible for doing this. Okay, I'm about to show you the answers. So you should have paused, you should have done them, and then we're going to hit play. Do you have it? Make sure you have it. All right, there are your answers. Okay, so now here's what I want you to do. I want you to summarize your notes. I want you to talk about like the similarities and differences in your notes, which was the same thing that you did for the check your understanding number 2. And then I want you to talk about why it would be helpful. So the check your understanding number 5. So in the summary of your notes, I really want you to focus on number 2 and number 5 as you're going through this. Okay, and then we're going to take a formative on this first thing tomorrow. I just want to be around to like help you answer any questions during the warm-up. So come with any questions that you still have. I don't want to give you a formative before I have a chance to answer any of those questions. So if you have extra time right now, what you can actually do is you can go ahead to the activity 2 practice, and you can start working through the activity 2 practice. So we will have our test on this on Wednesday, and that's what let's see, that activity 2 practice is on page 31. So that's what you can work on until the end of class. But your homework tonight is to summarize those notes.